call presplitting started from. That is the main origination of the presplitting term. The presplitting stands that will split the production zone from the unproducing zone, will split the zone of the rock block that is having the high grade rock, will split it away, will create a distance, an interface between them. Then before we blast the production zone, that is I'm trying to explain this in a bit so that someone that is not even a blasting engineer can understand what I'm trying to say. What I'm trying to say is that in the pre-splitting techniques, we have the production holes, we have the control holes or the perimeter holes. So the perimeter holes are the holes that is initiated first. They are the one that will split the production zone of the rock far away from the zones that is going to stand as the rock block or the mine face or the zone with less grade. So the main aim is that since we load the production holes more than the pre-splitting holes, there's a need to split to create another free phase air barrier between the production zone so that when the energy from the production zone is coming, it will interact with the pre-split, the split area, the split zone before getting to the rock that we are not interested in breaking, so that legs of the explosive energy will interact with the rocks that we are not interested in breaking or in creating discontinuity into. As I've explained in my previous video that during initiation, during blasting of a specific explosive or a loaded hole, two energy is released. We have the gas energy and we have the shock energy. The shock energy perform the work of creating microfractures, cracks into the rock, creating slabs, creating different microfractures into the rock, of which the gas energy now fill after the cracks have been created. So for us to reduce the rate at which the explosive energy will create cracks into the rock that we are not interested in breaking, there's a need to split, that is create barrier in between the wall and the production zone. So that is how pre-splitting work. Pre-splitting split away the production block away from the unproducing block. So since less energy will be released by the control hose, so it creates less damage to the wall and then create interface like free face for the shock energy. So the shock energy will have nothing than to reflect back into the rock as soon as it travels from the rock medium to the air medium. Also, I explained in my previous video that fragmentation, that is the cracking and breakage of rock, is achieved under three principles. We have the shearing, we have the compression or the crushing principle, whereby the zone closer to the hole being detonated tends to undergo crushing due to the fact that the compressive energy of the wave released at that point is of higher energy, higher compressive strength, greater than the compressive strength of the rock. So because the strength difference tends to allow the explosive energy to crush down the rock zone at the sides of the holes. So, and also the second technique is through shearing. Shearing techniques of fracturing is created due to the anisotropic and the heterogeneous condition of the rock. Since rock is anisotropic and rock is also heterogeneous in the case that it's composed of different minerals, like a simple mineral can a simple rock bearing mineral can have other minerals and other mineral grains in it. So due to the anisotropic condition, the response of each mineral, there is the difference in response of each mineral to shock energy. So one mineral tends to react in a different way to which another mineral will react. For example, a mineral containing quarks and also a rock containing quartz and also containing calcite. We all understand that calcite is of hardness 3 and quartz is of hardness 7. So the reaction of quartz, the resistance that quartz will offer to shock wave will be different to the resistance to which calcite, single calcite of 3 hardness 3 will produce. So in this case, like let's say the mineral is standing like this, in a bit for the shock wave to pass through these two different minerals, there is possibility of one of the mineral responding faster and the other responding very low, so stay standing, and the other responding faster, breaking apart. So due to this, there tends to be shearing at the face of contact between the mineral, thereby creating fracture. So the third principle, which is through the tensile slabbing, that is the failure of rock under tensile strength. So we understand that the tensile strength of rock is lesser compared to the compressive strength. So tensile slabbing occur through the reflection of wave after traveling from one medium to another. So this is where the efficiency of blasting, this is what makes the efficiency of blasting to depend more on burden and the position of free phase during fragmentation. The functionality of free phase is to ensure that the shock energy travel to and fro travels, reach the free phase and return back to the initiation point before the gas energy is being released. So the pre-splitting, which has already been the control holes, which has already been initiated first and have created a splitting between the production zone. So as soon as the production rock is being initiated, I mean the blasting zone, the explosive is being initiated, then all the shock wave traveling from the point of production to the point of splitting tends to reflect back, then creating tensile slabbing, reflecting without interacting with the rock face. And even if there is going to be interaction, it will be a bit. It will only be those explosive energy that is capable of traveling through the ear zone that will interact with the rock. Then the strength of the explosive shock wave will have reduced in and unable to create fracture into the face. So this is how splitting tends to help and prevent creation of discontinuity into the rock face. And also, how do we achieve the situation of initiating the production hose before the control hose before the production hose? This is achieved through the use of what we call the delay approach. The delay devices, we are the delay accessories, the blasting, which can be in electronics form, which can be in electric form and non-electric, through the use of uh, delay detonators. So the delay detonators are available in two forms. We have the surface delay detonators, and we have the down the hole delay detonators, that is the DTH. So these are devices or accessories, blasting accessories are used. The delay detonators has been designed in such a way as to prevent the timing between the surface initiation and the bottom and each hole initiation. So the delay can be in between holes, and it can be in between rows of holes. So this initiation sequence, the difference in timing is achieved through these devices. The devices have been programmed and has been designed in such a way that there's availability of it can be, if it is electronics, it will be capacitor shifts or capacitor shifts, yes, or current shifts that will reduce the rate at which the electric current that is coming from the exploder will get to the primer, that is the bottom charge, before causing the detonation in the primer, then down to the column charge. As we all understand, during blasting, the techniques and the approach is that each of the holes are being loaded with explosive, then connected to each other, then connected to a source that release the signal that will initiate each of the holes. So in a bit, the expectation is that there is a point that release instantaneous signal, then the signal is being distributed by the detonating cord or the connecting cords that is connecting each of the holes. So the signal is expected to be released from the exploder if it is electric, or from the blast cap, the safety and cap fuse, if it is non-electric. So as soon as, for example, the exploder release the current, then the signal is being transferred into each hose. Then the delay detonators absorb the current, then keep time interval before the current or the signal that is coming from the exploder could interact with the primary charge, the primary explosive that is available in the delay detonators. So in the delay detonators, there are primary charge, then there's current breaker or whatsoever, signal breaker, as the case may be, whatsoever you may call it in your own language or your own terms. So this current is being break, then delayed before interacting. So the current will be suppressed. Then as soon as the current gets to the primary explosive, then it will be amplified. So the timing between the signal from the surface to the primary explosive is what will create the delay time for the for the di- for the time difference in the pre-splitting holes, or the perimeter, or the control holes initiation time, and the production initiation time. So the same thing to the case of Nonel. So the same thing in that case, it's another method, it's another approach, but it's still the same thing. So the delay detonator delay the time. So in the delay in time, the production holes is reserved, unblasted. Then the pre-splitting hose or the perimeter hose is initiated. So at initiation, due to the charging method, due to the charging approach that is offered to the pre-splitting hole or the control hose, as I've mentioned earlier, that will control the shock energy by spacing, and also by the quantity of charge that is loaded into each hose. So because the production hose is being overloaded, is being loaded, not overloaded, is loaded down the control hose. The control hose being initiated with less explosive quantity, with less energy release. So the function of the energy being released by the splitting or by the control hose is to split the rock, that is create cracks interface, that is the production section at this side, then this wall is to be secured. So the production hose is placed, the control hose or the perimeter hose is placed at this point. So the perimeter hose tends to split the rock, creates a barrier, interface air barrier between the production zone block and the untampered or unblasted section of the rock. So as soon as we initiate this, remember this the pre-splitting hole has been initiated, and it has already split the hole and created barrier, at least air barrier, air, another medium, air free face between the two section, the two block. So as soon as the initiation, as soon as the detonation of the explosive at this section occurs, the shock wave tends to travel through the production row, the production blocks, and get to this interface. On getting to this interface, due to the barrier and the splitting condition of this particular section of the rock, the explosive energy is suppressed because of the difference in the sonic velocity of air at this point. Then it tends to travel back, reflected back, as just like the wave at when you observe an ocean, the way the ocean current tends to reflect on the wings, reflect on the water surface. It gets to the boundary, that is from the liquid medium. As soon as it gets to the solid medium, the wave tends to roll back the water. The same thing, as soon as the wave travels from the solid medium to the air medium, due to the difference in sonic velocity, the wave energy tends to travel and reflect back, so as to create tensile slabbing into the production hole. So the energy has lesser effect on this wall due to the splitting. So that is where the pre-splitting name is derived from. That is, the hose, the pre-splitting hose, or the preventing hose, or the control hose, or the perimeter hose, are to create splitting distance, another barrier, air barrier, between the production zone of the hose, of the ore, and the rock that is not to be blasted. So that's that on pre-splitting. Today you can still study more. You can study the work of Konya, the Konya constant used in the place of controlling the spacing for pre-splitting, and you can also study, as I've mentioned earlier, the specific formula for calculating the quantity of explosive that will be placed into the pre-splitting hose in the place of pre-splitting blasting, and there's a specific formula that's being used for getting the spacing for the hose that is used for pre-splitting blasting. So all this, you can study more on this, you can research more on this, but I'm giving you the prerequisite and the knowledge that you need to understand on pre-splitting blasting. Blasting is one of the techniques used in blast control to control the energy released by the explosive during blasting, and to ensure that the explosive energy perform have less effect on the rock face, or on blasted rock that is to be left behind as a support for the mine or for the bench. Thank you very much.